Can anybody aspire to be a cryptographer? What does lie behind this profession, and how does it tie in with blockchain? I had the privilege of talking to Philippe Aumasson, PhD in cryptography, author of well-regarded books, founder of several startups, former employee at the Kudelsky Group, creator of the Blake algorithm. Jean-Philippe started cryptography in the early 2000s, when it was not yet a buzzword. Jean-Philippe, I would love to know what is your background and how you became a cryptographer.
Yeah, first, thank you, Laura, for having me in this podcast. So my background is I studied computer science and math at university in France. So I did not do engineering school. I did not do the Grandes Écoles, but the most classical university. And then I finished with a PhD in Switzerland. So I moved from France to Switzerland, and I did my PhD at the EPFL, and at the same time at the Haute École Fachhochschule in near Zurich.
So what did you study before that? What was your passion or your interest? Was it like a straight path into cryptography, or was it more like a roller coaster for you?
So I'd love to tell you that since I was a kid, I was dreaming of doing secret code and decrypting secret codes, but it's totally not this. I was quite a confused and lost teenager, and at university I was even quite mediocre, a very average grade in math, and then I doubled 1 year. And then after doubling this year, I became much better. I got some interest in different topics, in computer science, in theoretical computer science, in artificial intelligence. And that's how I got interested in computer security and in cryptography, because cryptography is partially at the core of security and hacking.
So to go straight to the topic, what does a cryptographer do?
So you might think that cryptographers are only occupied at decrypting secret codes or even creating secret codes, or just concerned with data encryption. So encryption is the process whereby you take a message and you transform it into something that looks like garbage, that is not comprehensible. So there's part of this. So crypto is first and foremost about secret communication between two parties, two endpoints. So you can think today between two computers across the internet. But it's much more than encryption. So it's also about authentication, how you authenticate a user to a service. It's about signature, such as digital signature. And one major application of this is in blockchain and Bitcoin that you listeners might have heard about, where cryptography is really at the core of blockchains. And today, there are many more new applications of cryptography that go way beyond encryption. So I don't have time to explain, but I can give you names such as zero-knowledge proofs, such as multi-party computation, secret sharing. So the upshot is that now we have many different applications of cryptography, and that's why people sometimes call it the science of secret.
I like the science of secret. I guess it must really interest and inspire a lot of people and young people probably as well. So you were talking about hacking, actually. So was that part of your early life and an early stage of cryptography?
So hacking is quite unique as a skill in the sense that you don't really learn it at school. Well, there are some classes, some certifications, but the best people, they tend to be self-taught. And in my case, so I was in my early 20s, I had a computer, I had internet, and I had plenty of time on my hands. So I started, playing with my computer and getting interested on how the networks operate, and trying to get my hands with some hacking tools and trying to play with these hacking tools. I did not really know what I was doing, and I was clicking on things, running some programs, and at some point I got access to someone else's computer. I'm like, oh damn, that's interesting, and I could open their CD drive, look at their files. So it sounded pretty exciting for a teenager. So I dig a bit deeper into this and learned a lot, and that's where I'm here.
I'm looking at your academic background on LinkedIn, and it's very impressive. Can you tell me a bit about your master in computer science and then your PhD that you did?
I have quite an unusual path because in France, either you follow the university or you do the Grandes Écoles or the École d'ingénieur. So, however, I started in this normal, relatively basic university. And I ended up being one of the best in my class. But this year, the class was, to be honest, quite average. And from then, I moved to really the elite schools in Paris, École Normale, École Polytechnique, where I did my final master, which was a research master with a lot of math, a lot of theory. So I had to work maybe 5 times as much as my comrades who were from this brilliant school. They had really solid background in math. And I was really the outsider. So I learned a lot. I learned a lot also how to learn by myself, how to go find the right book, the right paper, how to do the right exercise. And I think that's a skill that is really useful, know how to learn by yourself. And that's also what helped me a lot in the course of my PhD and in the rest of my career.
What was your thesis during your PhD?
So my thesis, I don't even remember the name. So the thing is quite funny. I had a grant from the government, from the SNF, the Swiss National Fund for Research. And the reality is that we applied for quite a broad research topic. And I ended up doing research on different topics kind of tied to this grant official topic. So I wrote a bunch of papers, but not a single research direction. And I tried to gather all my papers and find a common denominator. And that's how I titled my thesis. And if I remember correctly, it was Design and Analysis of Symmetric Cryptographic Construction, something like this, but very, very general research area.
We actually know each other because of a common friend who was working for you during your years at Tesseract. I see that also you have founded quite a few companies. So I would love to know more about this stage of your life and also the new company that you created not long ago.
Yeah, thank you for asking about this. So after my PhD, I started directly working for a fairly big company, so the Kuderski Group, which offered me very good opportunities to work on very technical, very super interesting research projects in terms of security, in terms of software, hardware. And after approximately 10 years in this company, I felt like I was kind of at the prime of my career in terms of energy, in terms of motivation, in terms of skills and recognition. So that's when I decided to, fly with my own wings and try the startup game. And then I realized that I was a much better, let's say, hacker, coder, cryptographer than I was a businessman. Because I started a small company doing IoT called Tesseract. We had a very nice product that I'm proud of, but 0 clients. And about the same time, I met some people who are now friends and with whom I created this new company called Torres in 2018, which is about doing something quite different, but that involves a lot of cryptography. So we describe ourselves as a fintech for financial technology company, so a startup. And in short, what we do, we create the technology, so the software and some hardware components that we offer to banks and financial institutions to enable them to work with crypto assets, so virtual digital assets, as we call it. So it can include cryptocurrencies, what we call stable coins, and all other forms of tokenized asset, tokenized securities. So what's the link with cryptography here? So if you have this kind of asset, then to steal this asset, it's just about stealing a very small piece of data, which is the cryptographic key that you use to sign transactions or money transfers. So you can think of this as signing checks, except that all the process is based on cryptographic techniques. However, to steal the money, you don't steal stacks of banknotes, you just steal a very small piece of data. So that's why it's extremely important to protect it correctly, while at the same time giving people the capability to use it, to integrate it in their software, and also to have backups in case some disaster happens, like the computer crashes or the building burns to the ground. So you want to always have the capability to have access to your money when you need it.
Wow, it's something that's completely different from what I do or what I've learned so far. And it brings me to the next question. Are there any myths around your job? And what are they?
There are a number of myths related to cryptography and the related technologies. For example, there's a field of cryptography called post-quantum, which sounds very sciencey, science fiction. And there's this concept of quantum computer that you may have heard in the news. So quantum sounds impressive, even if you don't know what it means. I barely know what it is. And when you have this kind of brand new technologies like AI that is kind of related to crypto somehow, well, you might be under the impression that it will solve all the problems in the world, that it will be super powerful. So in the case of quantum computers, the biggest misunderstanding I observe is that it will not break all the cryptography. It will not crack all the codes. It can crack a small yet important part of the cryptography, but it's not a magically super powerful system. So it doesn't jeopardize all the cryptography, but only a small part. And the good news is that we have a solution, which is the field of post-quantum cryptography, or the crypto that comes after quantum. It's something that I've been working on quite a bit.
Let me go back to an algorithm that you have created. Could you talk about that?
In the course of my career as cryptographer, I created some ciphers, and more specifically, some algorithms that we call hash functions. So, which are relatively simple to describe. It's an operation that takes a piece of data and that transforms it into another piece of data that is fairly small and that looks random. So I won't go into the details, but I designed some algorithm during my PhD called Blake that was almost chosen as a standard by a very important standardization body. And I was a bit annoyed by this. Oh, I thought I had the best algorithm. So what I did is I created just a few weeks after an alternative. So the first one was called Blake, like the poet William Blake. And the second one was called Blake 2. You see, I have a lot of imagination here. And I designed it based on the needs of the users, the engineers, because there used to be a big gap between cryptographers in the ivory tower in academia and engineers. So long story short, now this algorithm Blake 2 is used quite a lot in many systems. So in probably all the computers you use on your mobile phones, even in some famous blockchain like Ethereum. And it's used not because it's elegant, not because it's very smart, but just because it's fast and it's secure. So the lesson here is that people only care about what matters, let's say, for the actual problem they have in real life. And they have no strong opinions about who is behind. I was not a famous person. They don't really care about how it works. They only measure the impact on their business, on their cost. And in our case, it really reduces the cost in terms of cloud computing CPU, for example.
For someone who would like to, who aspires to this career, are there any prerequisites, let's say, or any specific skills, be it soft skills or hard skills, that one should have in order to succeed in this field? Or would you say there is not any particular prerequisite?
So, there's a saying that goes by hard work beats talent when talent doesn't work hard. And in my case, as I said, I was relatively mediocre at math and not the brightest bulb of the team, but I was extremely motivated, extremely interested. And that's how I became arguably more successful than people that had maybe more solid foundations, but that were less motivated. So in our field, what helps is being good in mathematics, because there's a lot of not only pure mathematics, but the abstract thinking that you typically associate to math. How to reason about abstract objects and how to combine these objects. And then in terms of pure engineering, so if you want to be really useful in a company or in your own projects, you should not only know how crypto works in theory, but also know how to put it in practice. And most of the time it means how to write code, how to write software programs. So you need to know how to write code to some extent, but to know how to write good code, you need to know how the computer works. You don't need to know everything down to the silicium, to the silicon. But from my perspective, if you have good solid foundations about everything you do, that's the recipe for success in the long run. And that's how you will be better than your peers, because you have a better understanding of everything that happens. So yeah, the skill that help is math and computers. So these two sides of the same coin that is cryptography.
All right, thank you. That's a good advice. And is there any lesson that you've learned during your career that others could benefit from?
It's a bit cliche, so I've learned a lot of things, but I've always tried to challenge myself, do things that I thought I would not be capable of. Sometimes it worked, like when I did a book. I wrote a book in English, because English is not my native language. I never had written a book. And this book ended up being a huge success. And then I tried to found a company. And, according to the usual business metrics, it kind of failed. But I learned a lot of things regarding how you create a company, how you run a business, how you create, shareholder agreements, how you discuss with clients. So always see the opportunity. And in my career in this big company, Kudelski, what I quickly learned is that if you're in this kind of environment, corporate environment, you should not always ask for permission to do things. You should dare to do something and then see what happens. Because if you say, oh, I have this idea of project, or idea of this, people will give you 99 reasons why it will not work because they have no personal interest in it. But once you present them with a finished product, something that works, then everybody will find some positive aspect for them. And to do this, there's no magic. So I worked a lot, also worked on the weekend and night. But for me, it was a passion. It was something I love doing. So when you do what you want to do, what you choose to do, you get 10 times much better result than if someone tells you what to do.
Yeah, I see what you mean. I completely agree. Do you have a fun anecdote about your work, your line of work?
Well, not really an anecdote, but more an observation. So if we had done this interview 10 years ago, then probably we would not have done it because Laura would have said, oh, cryptographer, who cares about this? Because now if you tell people that you're doing crypto, they're all excited. Oh, crypto, cryptocurrency, blockchain, secret code, it's exciting. I kind of like it. Sometimes I don't like it. But 10 years ago, cryptographer and cryptography was far from being a household name. It was not really known, even by engineers to some extent. So it was more like, underground discipline, and now it became much more mainstream. So when I met people before, were like, crypto, what are you doing? And, girls would not talk to me. It was not cool. And now I have much more success. And the drivers behind this, I think there were two main drivers. It's first the revelations by Edward Snowden in 2013, who revealed large-scale surveillance by some American services using, bypassing cryptography. And the second big driver, of course, is all the blockchain ecosystem environment that started in maybe 2015. The other one is that, so I'm now known for my skills in cryptography, but I could not learn cryptography in my first year of my master's. So I registered to the class, and we had a choice of different classes, like computer graphics, database, and so on. And very few students registered to crypto because from the perspective of others, as I recollect, crypto was, it appeared as too hard, too mathematical, and the class was canceled. So I'm like, oh, damn, that's a bummer. So I ended up asking the teacher the list of the topics we would have discussed. And I found some books at the library. I found some resources on the internet. And I kind of simulated the course for myself. And, presumably I might have learned more things than with the class. But so my career in crypto did not start on a very positive note.
Yeah, that's funny. I wonder if many other people could say the same. It didn't really start in the West. And yes, I was looking at your profile, and actually, you were a cryptography engineer in 2009. So that was very, very early stage for not only for your career, but also for cryptography in general. And just a little bit about Kudelski, because maybe not many people know it. Could you just say a few words of what they do?
So it's a relatively little known company, yet extremely high impact on many people in the world, because what Kudelski was doing and is still doing is the security behind pay TV systems. So if you have some TV subscription, for football games and the like, so typically there are security systems behind to prevent people from watching without paying. simplify. And you might have a set-top box and a smart card. And in all these components, there are extremely sophisticated security systems. And I really had a chance to work there as a cryptographer because the problems are really interesting. So the attacker are people who own the device. So typically, you would try to attack someone else's device. You would try to attack someone else's computer or phone. But in the case of pay TV, people would legally buy a set-top box smart card, and then they would try to hack it to distribute the content for free and get paid for this, maybe from their neighbors and so on. So it started like this, and then it escalated to really advanced, organized criminal organizations in different regions of the world, having extremely high resources and high capabilities technically. And it was a kind of, cat and mouse game. We would create a countermeasure defense. They would maybe walk around it. We would find another one. And that's how we build maybe some of the most secure smart cards in the world.
It's fascinating. Fascinating. What advice could you give to someone who would like to enter this line of work?
I think today, when younger people are, lucky, compared to 10 years ago, because there's a lot of resources online. There's a lot of ways to learn. And there's many different subfields of cryptography. So like in any technical field, what is usually good is to specialize in one of these fields, maybe the one you feel you're the best at, the one that you like the most, but still be open-minded and learn about the rest. So for example, you're interested, in blockchain technology and derivative cryptography. So you should try to learn as much as you can about what is around. And not only the cryptography, so how the security protocols work, how the computers behind work, maybe what the business problems are being solved, what are the economics, because on the long run, that's something that will really, really help you and will differentiate you from other people who work in the same line of business as you are. So I read research papers about crypto, of course, but I try to also read about other topics such as physics, economy, history, and sometimes by pure serendipity, you find an idea in some completely different field that you can apply to your own field. And these are often the best ideas because that's the one that other people don't have.
And in terms of sources, are there any forums or any specific sites or conferences where people can go and exchange about these ideas or even meet professionals that they could learn from?
By far, the best resource you can find is my book, Serious Cryptography. There's only one resource. No, I'm kidding. So there's this book, which is quite for general technical public. So it depends on your background. If you have no background at all in engineering and in computers, you might want to learn more about the history of cryptography, about the basic notions. I think there's a good book called the Code Book by Simon Singh. If you like to learn about how to write code, how really it works technically, there are a lot of open source projects online that you will find, for example, on GitHub, which is the most famous platform. And if you want to go beyond that and learn about the latest research, the good thing is that everything is on the same site and on the same page. Well, most of the most interesting research is the what we call the Union of Cryptographers, the International Association for Cryptographic Research, ISER. So there's a server for research papers where every week you have an update with all the new topics. So even if you don't understand the paper, you might barely understand the title, it can give you an idea of the trends of what people are working on and what are the new developments.
Great, thank you. This is going to be very useful. And I want to thank you, Jean-Philippe, to be here and having spent some time with me on this podcast. And I'm sure you have inspired quite a lot of people. And hopefully maybe on your next book or next venture, because I'm sure you're not going to just stop at this one. We'll probably see each other again. Thanks a lot.
Thank you, Laura.
As Jean-Philippe says, hard work beats talent when talent doesn't work out. JP believes that he was mediocre at maths, but highly motivated, and that's what ultimately made him become more successful than others. Creating companies has also been a great learning curve for him, also those companies that failed in the business sense. His advice: always seek the opportunity, dare to do something, and don't wait for permission. Thank you, Jean-Philippe. Happy to have met you.